All right, here we go. Give the equation for the sinusoid shown at the right. And this graph that we're given here lends itself really well to be written as either sine or cosine. So we're going to write it as sine first because we just did the last one in cosine. But then we'll show you that you could have written the equation using cosine and had the exact same graph and show you how that can be. So let's start with sine. We're going to end up with something like y equals a times sine of b times x times the quantity x minus h, and then all plus v. All right, so what's that going to look like? And we've got, let's work our way through, what's our a value going to be? Again, we're going to take that midline. If you're not sure what it is, you would take the maximum value, add it to the minimum value, and then divide by 2, find the average of the maximum and the minimum. But pretty clearly we can see it's at 1 right here. Now that's our midline, so really we can even, that'll be what our V value is, so that'll be V, and that'll be at 1. But what's our A value? What's that amplitude going to be? So it looks like we're going up 2, and just to make sure, down 2. All right, so our A value is 2. So we got y equals 2 times the sine of, now b, that depends on our periods. Let's count our period. 1, 2, 3, 4. From any relative point to its same relative point. So we could do max to max, we could do min to min, we could even do 0 to 0, but same relative 0. So 1, 2, 3, 4, where it's heading up in both of those. But we can see that the period is going to be 4. So period equals 4, and actually I'll put this down below just to show our work on the side. So period equals 4. And remember that the period's equal to 2 pi over b, and solve for b. Multiply both sides by b, divide both sides by 4. Oops, that's the one I didn't want to cross off. And so we end up with b is equal to, what's that going to be, 2 divided by 4, so 1/2 pi. 1/2 of pi, so pi over 2 times x minus, now if we're using sine, this is kind of where the difference is going to come in. If we're using sine, we're looking for the 0 value. Think of sine, it starts at 0 and then heads on up. We're looking for the relative 0, the root of where that graph is at. That's the point we're looking at. And we can see that on the graph itself, it actually goes right there. We can see that 0 value pretty cleanly. Notice it's going down though from there, so that would affect our A value. Though amplitude is always positive, that A value, if it's negative, it's going to flip the graph top to bottom. It's going to reflect it across its midline here. Now, so it might be, there's a couple different ways we could write this sign. Let's use a positive one for right now, since we already had a positive 2 sign. And so that x value, how far has it been shifted to the right, is 2. So we could put x minus 2. Would have worked just as well to move it to the left right there, because again, it's going up from that value, in which case we would have x plus 2. It happens to be, whether we move left 2 or right 2, that's kind of the origin of sine. Lastly, the v value, it's been all raised up 1, so plus 1. That's one of the correct answers. We could have written y equals, remember we talked about how using the same origin value, the same beginning value for the graph, but having it go down from there. So if it's going down, that would be a negative 2 times the sine of pi over 2. Now that's going to change how far we move left or right. If we're going negative at the beginning, so basically just taking y equals negative sine of x, that graph's going to just be the same thing, but now upside down. So that's kind of what we're looking at, having to go down from there. In that case, x doesn't have anything being subtracted from it. It would just be x. And in your head, you can think of it as x minus 0. It still would have been raised up 1, so that would be a plus 1. But there's a couple different sign options just to give you an idea of kind of what you can do with these. Now, said also that we would talk about what if we had written it as cosine. So let's go through that fairly briefly. Y equals, and let's go with this here being our relative starting point. So we're going to have y equals, and it's the same amplitude, that hasn't changed at all. So 2, and if we're starting at the top, that's going to be a positive 2. If we had decided to start down at the minimum, we would have to have a negative 2. But we're going to start from right here, which is positive. So positive 2 times cosine of our period hasn't changed. So pi over 2 times x. Now this beginning point, the starting point for us is 1 to the left. So it's minus a negative 1. But instead, obviously, we'll write that as a x plus 1. Lastly, where's that v line? It's been raised up 1. So here's a potential equation with cosine. Again, an infinite number of correct cosine equations as well. Here's just one of them. And there we go. Hope that helps.